Okay, we're up to 2-5, day one. This is one of those things where if you were listening earlier, this should be, hey, wait a minute, this is kind of in the review lane, and you're right, but it's still tricky. So here we go. Start out with the basics. Get something like this. Hopefully your knee-jerk reaction when you see it is to go bada boom, bada bing, do the right thing. So we get plus or minus 7. All right. Now, if we get something that looks like this, we can apply the same thing. Now, a lot of people think, well, I'll just, multiply that all out. Well, then you're making it more complex. You can do it, but this thing is just on a silver platter waiting for you to go bada boom, bada bing, do the right thing. There's just a little bit more work. So x minus 2 equals plus or minus 7. Now notice we actually have two math problems to deal with. One of them is x minus 2 equals 7. The other one is x minus 2 equals negative 7. Add 2 to both sides, we get 9. Add 2 to both sides here, we get negative 5. So this creates a little bit more work. Now the reason I'm taking this progression here is because you're going to be given a few problems like this. Now again, there's more than one way to do these. But there's the simple way, and then there's the more complex way. We're looking for you to kind of look for the simple way. And I've been trying to get you guys to look for perfect square trinomials. Remember, it's like trying to get your attention. At least that's what I think. Like, wait a minute, that's a perfect square trinomial. That'll factor right into x minus 2 times x minus 2 equals 49. Like, well, that doesn't look any easier. Well, what if I wrote it like this? And now this problem is the same thing as that one. So I would just go bada boom, bada bing, do the right thing. It's the same problem. It's just given to you in a little bit more of a complex way. But this perfect square trinomial should jump out at you. It'll make your life a lot easier. Are they all going to be like that? No. So that's why I have this one on here. Is this a perfect square trinomial? No, it isn't. So this is where we're going to have to complete the square. We've learned this before. So remember, rule number 1, this has to be a 1 in order for us to complete the square. Rule number 2, we want to bump this over. Remember that? And create spaces. So when I taught it the first time, I said create a space, bump it over, create a space, and then this time we have equals 0. There's nothing wrong with that. But in this, because these are different, we're going to really bump it over by subtracting 5, subtracting 5. Watch this. Create a space here, negative 5, create a space here. Why are we doing this a little differently? I'm going to show you. Because this is a 1, I go to my middle coefficient, take half, square it, that's 16. Now, if I put a 16 on this side, to keep it balanced, I got to put a 16 on that side. Now, you guys might remember, oh, wait a minute, I thought you said do the opposite. That's when they're on the same side of the equation. Now they're on opposite sides. So if I add 16 pounds to this, I got to add 16 pounds for this in order for it to be equal. Now notice what we have. There's our perfect square trinomial, which I hope you guys are getting good at this. X plus 4 squared equals, that'd be 11. Why is this beneficial? Because now I'm ready to go bada boom, bada bing, do the right thing. So I get x plus 4 equals plus or minus the square root of 11. Now, if we subtract 4 from both sides, we get x is, notice we can't add these together because they're not like terms, negative 4 plus or minus the square root of 11, which is a different way of saying negative 4 plus the square root of 11 and negative 4 minus the square root of 11. Let me pause this a second. Okay, so what's the difference between this one and this one? Well, this equals 0. This one equals 6. I'm just throwing this at you because there's a few sample problems, homework problems, they're going to be like that. They're not all equal to 0. But you see, this is not a perfect square trinomial. So I'm going kick this to the curb, which means get rid of it. And then I say, okay, x squared plus 8x plus blank, that's where my perfect square trinomial is going to come from, equals 1. Now, same thing, take half of that, 4. Square it, 16. Because I added 16 to that side, I have to add 16 to that side. This is my perfect square trinomial, x plus 4 squared equals 17. Now I'm ready. Bada boom, bada bing, do the right thing. X plus 4 equals plus or minus the square root of 17. Subtract 4, x equals negative 4 plus or minus the square root of 17. All right, I got one more sample problem to show you in this. Okay, this one's a doozy. This has a lot going on. So, hopefully you've been listening. This has to be a 1. We'll get to that in a minute. Now, do you think I should divide everything by 2? It's a good idea. It'll work. But what we're going to do is take a look at this and follow our program. We're going to take that over by subtracting 1, 2x squared plus 10x, and then plus blank equals negative 1 plus blank. Now, we don't have any way of getting a perfect square trinomial. We could still divide by 2. Now, what we've been doing, though, is we've noticed we have a factor that we can take out of here, and then we would take a 2 out. We'd be left with x squared plus 5x. You know what? I'm going to change something. Rather than doing this whole video again, I'm going to make this a 12. And the reason is we haven't dealt with an odd number yet, and it just gets a little crazy. We'll deal with some of them, but not quite yet. So what happens? Well, if this was a 12, and I took a 2 out of that, I'd be left with x squared. Take a 2 out of that, I'd be left with 6x. I have it, don't panic, cleatfish, plus blank equals negative 1 plus blank. Now, because we want a perfect square trinomial over here, we can divide this side by 2 and divide this side by 2. We'd end up with x squared plus 6x plus blank equals negative 1/2. Like I said, you could have divided that all by 2 right away and gotten x squared plus 6x plus 1/2. Then equals 0, subtract 1/2, subtract 1/2, and you would get the same thing, just differently. So this matches what we did when I covered completing the square the first time. That's why I wanted to show this technique, but this is fine. We've got to have a 1 here. So what do we do to that? Take half. That's 3. Square it, 9. But if I put a 9 on that side, I got to put a 9 on this side. Now watch what happens. It gets a little messy. This is a perfect square trinomial. That was our whole goal. And then we get, 9 and negative 1/2, that's 8.5. Don't you dare use that. 9 minus 1/2, 8.5. Don't you dare use that. This right here is 18 halves. So we would get 17 halves. See, introducing this is going to help your algebra. It's going to take you to previous lessons. So now we go bada boom, bada bing, do the right thing. So we get x plus 3 equals plus or minus the square root of 17 over the square root of 2. I'm just writing it a little differently. What I'm going to do right now is take a look at here and say, wait a minute, we don't want square roots in the denominator. So I'm going to multiply the square root of 2 square root of 2. So I'm going to rewrite it. I think I've got space over here. X plus 3 equals plus or minus the square root of 34 all over. When you square a square root, the roots fly off. And I'm one step away. Subtract 3 from both sides. X is negative 3 plus or minus the square root of 34 all over 2. We weird looking answer. Now, rather than showing you a whole nother example, I'm going to throw a what if at you. What if this was a negative? That would make this a negative. That would make this a negative, and this a negative. So I'd have one more step. That'd be -3 plus or minus I square root of 34 all over 2. Just take the I out if that just happens, and it will. So be on your guard for